Hello, in today's Arduino project, we are on project number 14, Tweak the Arduino logo. If you have stuck with me through all these projects, good for you. That's awesome. I'm sure you've learned a lot. I hope you've learned a lot, and I hope you've enjoyed it. I have one more project of this series, and then I may go back and do some others, but you're almost done. Hopefully this one actually works, because number 13, they didn't have the needed libraries in the TinkerCAD simulator. So if this is your first one, I urge you go back to the starters, and then you can go ahead and work your way up to this. So stick around. Be working with you soon. All right, so here we are, project 14. In order to get here, you log into TinkerCAD, then you click on Learn. Make sure you switch to Circuits, go to Lessons. I have videos on, go to Projects. I have videos on every single one of the green-backed ones so far, and we're on 14. Maybe by the time you're watching it, we're on 15. Click on 14. Please restart the project if you've already started it. And let's begin. So in the introduction, this does tell us what we are doing, just like that main screen. This is a breadboard. This is where we can connect our components. And we can connect wires to those components without having to solder or anything like that, okay? It says in this project, you can use your Arduino to control your computer. You will take full advantage of the serial communication between the Arduino and your computer to change the color, excuse me, of an Arduino logo. This project requires your physical Arduino kit. So although we can go through this, just like last time, the simulator, for some reason, they haven't set it up so it actually works. I do love that we can see the microbit. That one's a lot of fun. I use that in my class. All right, so if you're doing it on the simulator, you can just sort of imagine how it works. I'm sorry that that's how that works, but they did not set up the full simulator, but you could learn a lot still, and I'd suggest just going through it. You're going to take control of your computer with your Arduino, or at least you will take control of one application. When you program your Arduino, you're opening a connection between the computer and microcontroller through a serial port. Just like when we run our code, we have our serial monitor. There's a serial port, and it can control things, just like when you type on your keyboard. When the Arduino does something, it can send a command to your computer. You'll be using a very simple interface, a single potentiometer, to control the color of the Arduino logo shown above. You'll program the Arduino to communicate data from the pot, through the potentiometer, through the serial port. Then you will use another programming environment called processing to tell your computer what to do with collecting data. So let's go next. Since this project relies on another programming environment called processing to work, you won't be able to prototype the project in the simulator. You will need to use your Arduino kit to build it. All right, so let's just talk about how this works in this, and then you can figure it out with your physical kit. And I apologize, I can't show that to you on this. So you'll be using a programming environment called processing to write code that interprets the serial data coming from the Arduino and translate it to take action on your computer, changing the color of a picture. Arduino's programming environment is actually based on processings. They look pretty similar, so you should feel right at home there, okay? All right, let's move forward. We'll set up the circuit. So setting up the circuit, obviously we will need some very basic things. First of all, we connect 5 volts to our positive rail. We make that red because it's good to keep it organized, and red means positive. Ground to the negative rail, and we make that black. Once again, that makes all of these ground and all of these positive because these are connected in that direction. Continue to the next step. This one's nice and easy. We take our potentiometer, we connect it at 16 and 18. So we grab our potentiometer, do it at 16 and 18. I know these don't look exactly the same, but they do work the same. If you're doing this in, with your physical kit, that would work as well. You'll notice that the connection to this potentiometer is on the other side of the breadboard, so it needs to run there. With the one we're using, it's right here in the center, so I will be connecting it a little bit differently. This one goes to A0, and they had it purple. The nice thing about using the simulator is you can mouse over, and this says terminal 1. This says white. I'm going with white. Yep, and terminal 2. 16 runs to positive, and then 18 runs to negative. So we've got 16 running to positive. I'm just going to do it straight down, and negative. Let's make those colors match. Let's talk about what it's doing. You should probably already know since you've gotten to this point, but it is running electricity through this potentiometer. The potentiometer, depending on where this is, allows more or less electricity through it because it's a variable resistor. And so depending on how much electricity is being allowed through it, it will send a reading to our analog in where it will read it. Nice and easy. All right, and then let's look at our code. Normally I don't do this, but I figured I'd go through it. If we go to create.arduino.cc, we click on web editor. Normally I don't show that step because I don't know, I guess I open it up early. Click on examples, and now some of these might be a slightly different name, but it's always under starter kit, and we'll go down here, tweak the Arduino logo. So that one looks like it's the same. And here is our code. I'm going to copy all that code by pressing Control A and then Control C, and we'll come back here. Now let's move on to writing the code. As always, I don't really enjoy how they write their code on TinkerCAD because it doesn't include the notes. So I like to replace it. It looks like they already have that on there. I'm going to replace it with the code, and we'll walk through it. This is once again, and we should always give credit to Scott Fitzgerald. He did a wonderful job writing on this, writing the code. At the beginning, it does its setup. It's turning on the serial at 9600 baud, I believe that would be, and then it runs a loop, and it says read the value of analog 0. Okay, divide it by 4, which is just what we do with that, with input from the potentiometer to make it meaningful, and then delay by 1. And that's it. That's all it's doing, right? So it's sending information. If I hit start simulator, watch. That didn't work. Wonder why that didn't work. That's interesting. Now I'm going to delete these just in case it's, an issue with, let's see. Oh, that's funny. So we didn't, we didn't say digital write to it, but that's all right. All right. So it is getting a reading. It is getting a reading. It's just not writing it to the screen, to our monitor, but it is sending that value. And if we go through this, it says in the section you're going to write and save a very short Arduino program in Arduino IDE. If you're doing this with your physical kit, you would actually open up that program and run it, not do it here. Copy the code in. We did that. And I actually want to get back all my notes. Okay. And send the sensor value by doing that. Now, they added serial print, which I agree with. I'm guessing Scott Fitzgerald, you don't need to do that, but it's a good thing to have. So I'm going to have serial print. Now remember, capitalization and all those, spaces and spelling really, really matter. And if you mess up on it, it is not going to work. Okay, that's a 0 divided by 4. So you'll notice we're doing the same exact thing that we did here. But this is going to write to the serial port, and this is going to print to the serial port. So now when I run it, we look at our serial monitor. It should be giving, and you'll see that it does say 255. And as I change that, the value will change. Why is it giving those letters? That one, I don't know. I could look into it more, but you'll notice as we change it, it does, right? The value changes that it's printing out. I'd ignore the letters for right now. and the symbols. Awesome. All right, moving forward. Upload and test the sketch. So we just did it. You would have to upload it to your board when you're doing this with the physical board, and then you could test it, and you could turn on your serial monitor and you would get a reading just as well. Now, it's always good to do that serial print. The reason why is it's really nice to be able to see that reading. Whenever I have a new sensor, like I have a box of sensors back here, when I connect that sensor and I need to figure out what readings would matter, I connect the sensor on a serial read like that, on a serial print, and I read those values, and then I'm able to choose what I want it to do based on what input it's getting. All right, moving forward, writing the processing code. Now, this is going to be different than normal. It's going to be different than normal, and we'll go over here. It says, in this section, will you use the processing programming environment to write code that will interact with a picture file that will download from arduino.cc/logo. So you go to that website. The processing language is similar to Arduino, but there are enough differences that you might want to look at some of their tutorials and the Getting Started guide to familiarize yourself with the language. Now, I'm not planning on making tutorials on that as of right now, but check back in the future and maybe I will. It says open up a new processing sketch on your computer. Processing code. So we need to actually download the program to do that. It's a new program. And the website to go to, I apologize, will be processing.org/download. And then just choose which version you need. I need Windows 64-bit. Now you'll click on this and it'll say we need your help. Of course, if you want to donate money, please do, especially if you're going to use this program pretty often. But it does download without donating that money. So that's something to know. But if you do use it pretty often, you might want to actually donate. So give me just a second and I'll open that up. All right. Now that took a surprisingly long amount of time on my computer. I'm not sure if you'll have the same thing. You will have to unzip the zip file if you're on Windows, and then you can just open up the .exe in that file. It does come up with this little thing. Feel free to go through it. I'm just going to be following the directions in here, though, and we'll sort of go back and forth on this. Now, a really nice thing you can do is you can press Windows and then the right button. It'll put it to the right side, and then I'll put this on the left side, and so I can have it side by side. Okay, and since we're not setting up components, I don't believe I need this anymore, but we'll see how it goes. So moving forward, it says in this section, we're going to be using this. Wonderful. It says copy the code below into processing. So you could click in here. Maybe press, no, you can't press Control A. So just click and drag, Control C, move over here, Control V. That was quite a lot. That was not the actual code. So maybe right click. That was my code for the Arduino. There we go. It says processing. Oh, we read this. Okay. Notice that the processing code is also color coded, but in a different way than Arduino sketches. So you'll notice it says import, that's blue, and then this is black, and that's underlined yellow. That might be my computer. But it does say the value of the local variable my port is not used, right? So we'll go through that. Next, it says to use images in processing, you need to create an object that will hold the image and give it the name logo. So we are going to call something Pi image. New line, okay. Paste it. We'll get to that in a minute. Create a variable. It's funny that it's called Pi image. I feel like it should be Arduino image, but P image? P image. Yeah, I guess it's P image. I don't know. Create a variable that will hold the background hue of the Arduino logo. The logo is a PNG file and has built-in transparency. So even though this is white, we could change that color whenever we want. Okay, copy the code below into processing. So we will say we have this variable that is called BG color, and we'll say that's equal to 0. My computer just told me that I may not be saving my video. Hopefully this is working. All right, so then we're moving forward. In this program, you're going to use a color mode called HSB, which stands for hue, saturation, and brightness. You'll change the hue when you turn the potentiometer. So then copy the code into it. So you'll notice this is very, very, very similar to Arduino, right? Because now we have a void setup saying this color mode HSB and then 255. It says color mode takes 2 arguments, the mode and the maximum value it can expect. To load the Arduino image into the sketch, read it into the logo object you created earlier. Processing will download it from the URL when you run the program. That's really cool. With the size function, you tell processing how large the display window will be. When you use the logo.width and logo.height as the argument, the sketch will automatically scale the size of the image. So we're going to copy it, run a new line. Some of these programming languages, the indent really makes a difference. Since we're in void setup still, I'd imagine we want it indented there. It says logo, load image. Here's the location for it. Hopefully it's still there. I'd imagine it is. And then it says the size. It says print available serial ports. Processing can print out status messages using the print line, I believe that's an L, command. If you use this with the serial list function, you'll get a list of all the computer's serial ports when the program first starts. You'll use this when you run the code to see what port your Arduino is on. So let's run this, copy it, paste it. It says missing right curly bracket. So this is debugging as we go, and I'm hoping that just means because we haven't ended this void setup yet. Hopefully it's working well. Next you need, I don't know if you notice, it's giving us these messages down at the bottom. And as we go through it, it'll tell us if there's an issue. And right now the only issue is it's missing this, which is fine because we're not done. Next you need to give the processing some information about the serial connection. To complete your named serial object myPort, the program needs to know it is a new instance of a serial object, so just something connected to the computer. The parameters it expects are which application it will be speaking to, which serial port it will communicate over, and at what speed. The attribute that tells processing you're going to use the serial connection is in this specific application. It will grab the first available serial port from the list you generate in the last step. The argument 9600 should look familiar. It defines the speed at which the program will communicate. So you'll notice now, let's add a new line and paste it. You'll notice now this ended our void setup, and then they put a note saying end setup. This bracket, the void setup started at this bracket and it ended here. We're setting up a color mode, loading our logo. That's spelled wrong. All right. Print available serial ports and then give a list of those serial ports and then set up a new serial port and then end your setup. Now we need, I would imagine, a loop. Start the draw function. The draw function is analogous, that's the word, to Arduino's loop in that it happens over and over again forever. This is where things are drawn to the program's window. So copy the code into your processing sketch. So it's just copy and paste. It's on its own. Move forward. Now it doesn't have the end bracket, right? Check if there's information from the Arduino by seeing if the available port list is populated. The myPort.available command will tell you if there is something in the serial buffer. If there are bytes there, read the value into the BG color variable and print it to the debug window. So copy the code, and this will end that void draw. Now I'm going to start a new line. Okay, keep it nice and organized. Now it's saying it's missing the right curly bracket, so perhaps we can't put it on the... Yep. Let's try that one more time. So for some reason, it's still saying we're missing the right curly bracket, and I hope that doesn't cause any issues. Oh, it looks like, that's why, because it started here. This one ends that one. This one still isn't ended. So moving on to the next step and the last step, I believe, display the colored image. The function background sets the color of the window. It takes 3 arguments: hue, brightness, and saturation. When we look here, we've got hue, brightness, and saturation. That's what those stand for. So this 2 is the hue right now. The 5 is the brightness, and the 5 is the saturation. And they said that's the max value it can get. Use the variable BG color as the hue value and set the brightness and saturation to the maximum value, 255. You'll draw the logo with the command image. You need to tell image what to draw and what coordinates to start drawing it in the window. 0, 0 is the top left, so start there. So now they just want us to copy this code. Sorry about that. Just need to copy that code. And we are going to paste it. Now you'll notice that this ends that draw. So the bracket here, there's a bracket here that's ended here. The bracket here is ended here. Brackets normally cause people issues in programming, so it's good to pay attention to. And now I'm going to hit done. And now we move on to change the logo color. All right, now I'm not sure if you're going to have issues getting to the next one. For some reason, I couldn't get to the next lesson just by clicking next or done. I had to go back to the project page and then click on change the color logo, change the logo color. I don't know why that was, but you might have to do that as well. So we've already done the processing programming. Now we've set up our thing. It says now we'll actually start playing with the logo. Now my simulator, I won't be able to show you it, but I hope that you're doing this in real life and you'll be able to see it. Now that all of your code is written, it's time to take control of the Arduino logo with your project. So connect your Arduino and open the serial monitor in Arduino IDE. So all right, if you want, if you're doing this with your Arduino, I'd imagine this is you've already done this. But if this is the first one you've done with the physical Arduino because you really haven't had to do it up until the last project, you want to go to arduino.cc, go to software and downloads, and then download the version that you need, okay? I'm just going to download the zip file because I don't want to install it. Obviously, you can contribute money. Great idea. Support them. And then I'll be back in a second once it's done, and I'll open it up and show you what to do. All right. So it said once you download it, come back here, right? Connect your Arduino and open the serial monitor in Arduino IDE. Now, I'd imagine they want this programming in it. So if you hadn't done it in there yet, copy it and then go to, this is Arduino IDE. It's similar to that, to the processing.org one. And you just want to paste, right? And then we have these tools up here, and there is a serial monitor. Now, I'm not connected right now, but you'll click serial monitor, and it'll look just like that. All right, again, you will see 2 types of data coming through. When you use serial print line, you send information formatted for the serial monitor. When you use serial write, like in this application you're writing now, you're sending raw information. Programs like processing can understand that raw information. So when I say run, all right, well, this can't read it. That's all right. This was in processing. Oops. All right. Moving forward. Don't do that. All right. Run the processing sketch. So close the serial monitor and run the processing sketch by pressing the arrow button in the processing IDE. So if we go into the processing IDE, right, and we hit run when it's connected, right? You need it connected. And then we have this next to it. Let's see if I can get all these on the one screen. So you'll have the Arduino connected. If you're having connection issues, by the way, just make sure you have the correct Arduino chosen and the correct COM. If I choose this is actually one of my ham radios. That won't work. And then have this. They want you to run this, and then while this is running, press Tools, and then Serial Monitor, okay? All right. It says, take a look at the processing output window. You should see a list similar to the figure below. All right. Okay. It says start If you're using OS X, look for a string that says something like DEV TTY USB modem 411. It will most likely be the first element in the list. On Linux, it'll appear as USB 0, or similar. For Windows, it'll appear as a COM port. So the same one you would use when programming the board. The number in front of it is the serial list array index. Change the number in your processing sketch to match the correct port on your computer. All right. So when we are looking, let's look at that information again. If we're looking at our serial list, my ports. All right, so you need to make sure that it is connecting to your port that you have chosen. It says start running the processing sketch by pressing the arrow. Look at the list of serial ports at the output. Find the first serial port on the list with the correct name format. Change the serial list array index in your code to match the port you just selected. So when we go to serial list right here, you want to say which one it is. Now, if that doesn't work, remember, programming 0 is our first value. So if it's the first port, maybe you enter the COM number or the port number, but you might also have to list whether it's like the first, second, third, or fourth. You probably only have one listed anyways. So that's either going to be the COM number, or it's going to be like a 0 for the first one in the list, or a 1 for the second, and so on. If it's not working, just change that number until it does work. Hopefully you don't have that many COMs listed. Okay, then we click next. And then after you change the serial port index, restart the processing sketch. And the way to do that is to just hit stop and then play again. When the program starts running, a new window with the Arduino logo will pop up, and I'm going to save that for you, okay? Turn the potentiometer attached to the Arduino. You should see the color behind the Arduino logo change as you turn the potentiometer. Now, if that doesn't pop up or it doesn't work, you probably have the wrong COM chosen, okay? But remember, you're playing this is running, and then you're going to have your serial monitor running as well. You don't need to, I don't believe, but you should be all set. So comment below and tell me how that worked for you. I will finish this, but once you've twisted and turned to your heart's desire, try replacing the pot with an analog sensor. So change the potentiometer to a different sensor, maybe a light sensor of some kind. Remember to look through all those different sensors that we have. Let me close my code. You might have a bunch, but we can look through here. Oh, it's too bad. I thought they listed it as sensors. But definitely another potentiometer, that would work using potentiometers. You could use a photoresistor like we've used before, maybe a temperature sensor. Maybe you hold on to that, and as the temperature changes, the background color changes. Anything like that. Anything you'd like to do with that would be fun. And post in the comments below. Tell me if you got it working. Tell me if I missed a step, and then tell me what you've done with it. That would be really, really nice to know. So congratulations on taking control of the Arduino logo with processing. In this project, serial communication enabled Arduino to talk with a computer application. With processing and other programming environments, you can control media on your computer in some remarkable and novel ways. For example, and the one that stands out is microbit. This actually you can connect, and you can make it, you can make like a special controller and send out LED arrays by using Scratch, which I have videos on as well. I have something called Makey, which is a lot of fun as well. You can make anything that somewhat conducts electricity into a controller. So like I'd touch my one son and it would make a sound, and I'd touch my other son and the computer would make another sound. So there's some fun stuff you can do with it. Maybe I'll make a video on that sometime. If you're excited about the possibilities of controlling content on your computer, take some time to experiment with processing. There are several serial communication examples in both the processing and Arduino IDEs that will help you explore further. Something I'd also like to point out, in TinkerCAD, there are a lot of wonderful ideas. If you click on Learn and then you choose Circuits, is it Projects? There are obviously all of these. There's also a gallery, which you can choose. You can choose circuits, and you can get a bunch of ideas as to what people are using the Arduino for. If you have something specific you're looking for, I believe there's a way to search as well, right here. Okay, so I hope this was worth your time. I know it's a little weird not being able to work directly on the simulator, but I hope you're learning a lot, and thanks for checking it out. See you later.